Bulldogs, I'm about to give you one of the most valuable exam tips I could ever give you, especially for you experienced networkers out there who are diving into the CCENT and CCNA exams. We've got some network services and protocols that run so flawlessly. I always say almost flawlessly, but it's to the point that you and I, in our jobs as network admins, we really don't give them a whole lot of thought on a day-to-day basis. We don't go in and say, oh, we got to watch ARP in action today. Because it works so well, we usually don't have to pay any attention to it. The problem with that is that experienced networkers tend to gloss over these topics in their studies, and that's what comes back and bites them. Because what we're going to see here are some nuts and bolts as far as ARP and DNS and especially DHCP, and we're going to see how these three protocols work. But the key is, this is not something we look at every day in real-world networking. You can go months and not even think about DHCP because it works so well. But for your exams, you better be prepared to explain here's how it works, etc. Here's how I troubleshoot it, here's what happens next, that kind of thing. So this is definitely not a section you want to gloss over. This section could be worth 100 points or more on your exam. So let's go ahead and dive in and talk about first about this one data transmission but two destination addresses. And again, this is something that as network admins, you and I don't think a lot about the layer 2 address because we spend so much time concerning ourselves in working with layer 3 addresses. We have to make sure they get assigned. We have to make sure sometimes they get filtered. Then when we're writing ACLs, we're almost always writing IP addresses. So we don't think about the MAC addresses that often. But data going from host A to host B in this scenario and any other, it's got to have a destination IP address, sure, but it's also got to have a destination MAC address. So host A has got to have an L2 and an L3 address for host B before it can send data to B. Now, to get these two required destination addresses, host A is going to use these two protocols, the domain name system DNS for the IP address and the address resolution protocol ARP for the MAC address. DNS you're probably very familiar with, but ARP you might not know the details, but we're going to talk here about both. Host A is going to need the IP address first because, as we'll see, it has to have the IP address of that remote host, of host B in this case, in order for ARP to work properly. Let's take a quick look at how DNS works. Now, host A is going to know the computer name of host B, and for this discussion we'll assume it to be host B, all lowercase with no spaces. Now it needs an IP address and a MAC address for that host name, and it's DNS that helps it get that IP address. Now the DNS process is very straightforward, very simple. Every host will have the IP address of a DNS server, and a host that needs the IP address of another host sends a DNS request to the DNS server. And note that all devices in this example are on the same network segment. There are no routers involved. And it's simply host A asking the DNS server, hey, what's the IP address of host B? And the server is responding 10.1.1.2. Now, the first natural question is, how does host A know where the DNS server was in the first place? Because if host A doesn't know the IP address of the DNS server, then we're in a lot of trouble. Well, that's going to happen in one of two ways. Either the DNS server address is hard-coded on host A, or, much more likely in today's networks, the DNS server address was learned via DHCP. What I'd like to do right now is bring up a PC, and we'll come back to that, but let's bring up ipconfig all. A lot of information here on this particular box, but here we'll go up to the wireless LAN adapter because that's what I'm using. And we see all kinds of information here about a MAC address, an IP version 4, and a link local IP version 6 address, and a DHCP server, etc. And the DNS servers are always going to be near the bottom of that particular output. And it learned about those from DHCP. Now you'll notice, bringing that back up actually, there's nothing here about an ARP server. And that's because we really don't have an ARP server. And we're going to see how ARP works now, because now that host A has the IP address of host B, we're halfway home. But now host A needs that MAC address to send data successfully to host B. And host A is basically saying to itself right now, hey, I've got host B's IP address, that's great, but now I need the MAC address. Well, ARP does not have a server the way the DNS does, as I mentioned. The ARP process uses a series of broadcasts and replies. Now, host A is the host that needs the MAC address of a remote device. So it's going to be host A that sends out the initial ARP request. And this request is a layer 2 broadcast. And what this means, the source MAC address of this request is going to be that of host A. The destination MAC is going to be the all F's address because that is our layer 2 broadcast address. The source IP address will be that of host A, and the destination IP address will be that of host B, which was learned via DNS. And here's our scenario, and I'll go over those again very quickly. Host A is sending the request, and that is a layer 2 broadcast, so it's going to the all F's address. And what the ARP request is, basically it's yelling, it's a broadcast. It's saying, hey, if your IP address is 10.112, I need your MAC address. Now, since we've got a switch in the middle of this network, we know, and since this is a broadcast, everybody else connected to that host switch is going to get a copy of that broadcast. So, host C will see it, and the DNS server will see it, and then they'll look at it and say, well, okay, it's looking for the MAC address of 10.112. That's not me. And they simply ignore it. Now, host B will see that it's an ARP request, and it does match its IP address. So host B then sends an ARP reply containing its MAC address, saying, hey, I am 10.112. I'm the guy you're looking for, and my MAC address is all B's. So that is our ARP request. Now, thanks to DNS and ARP, at this point, host A now has the IP and MAC address of host B, and it can send data to the host. No problem, right? Well, it's a nice, neat little process, but we've always got room for improvement. We're always looking for ways to get better. Now, those ARP requests are broadcasts, and while we can't eliminate those, we'd like to minimize them. And wouldn't it be great if the PC could keep a list of MAC addresses that it learns for a while, perhaps a cache of addresses? Well, you saw that actually when I brought the screen up, that I was looking at the ARP cache, but I'm going to run that command down here one more time because you want to put the -A or -A switch after. It's ARP -A. And here's your mapping. Here's your mapping of layer 3 addresses to layer 2 addresses. Some are marked as static, and some have been dynamically learned. But that's a nice cache, and that way if we want to communicate with any of those devices in the next few minutes before they time out, then we're good. We don't even have to go through this process. Now notice that table mentioned physical address, and I'll bring it up again because that's definitely worth repeating. That's one of the terms for MAC address. I know you remember that. We looked at that earlier, and I said, hey, sometimes these are called physical addresses. And we see here they are called physical addresses, but they belong to layer 2 of the OSI model, not layer 1. So just something to watch there. Now, after learning host B's IP and MAC addresses, host A would then enter them into its ARP cache. The next time A needs to send data to B, the information needed to do so is right there in the cache, and you wouldn't need to send a request. Now, in our previous example, one we just walked through, we had a switch in the middle of our network, and that doesn't affect the ARP process at all. Switches don't have any problem forwarding the broadcasted ARP request, and that ARP reply that B sent back, that's a unicast. So we don't have an issue there, period. But if we have a router in the mix, we do have a problem because routers don't forward broadcasts. Now in this illustration and the following ones, I've taken the switches and the cables out of the mix just for clarity's sake. But let's say that there was a router in the way, and we've got a couple of Ethernet interfaces here. Host A sends a request for host B's MAC address. Well, it's going to stop right there because the router's going to say, hey, I don't have anything to do with broadcasts. But all is not lost. Using something we call proxy ARP, the router can answer the request with the address of the interface that received the response. Very important detail there. The interface that received the response, which in that case would be Ethernet 0. Now, just as a proxy vote is cast by someone, a representative, because a person can't be there for a vote, proxy ARP is being used because the router knows it can't forward that broadcast, but it's going to say, okay, I'm answering it. Now, what happens here again, here's the proxy ARP response, and it's with the router's E0 MAC address. Because remember, both of these Ethernet interfaces will have separate MAC addresses in the router. Host A doesn't have the faintest idea that the MAC address it received in the ARP response is not that of host B, but rather that of the Ethernet interface of the router, E0. Host A doesn't care either. Couldn't care less. All host A knows is, hey, I sent a request out and I got a response, and this is the address I'm going with. Now, when host A sends data to host B, the data is going to have the following destinations. The IP destination address is still going to be that of host B, but the MAC destination address is going to be the one assigned to the router's Ethernet 0 interface. Now, proxy ARP is a little odd to work with at first, takes a little getting used to. It can result in some unexpected source and destination MAC addresses at different points in your network. I want to take this a step further and show you another illustration where we've got maybe a couple of routers involved, a couple of hosts, and I want to walk through and take a look at how the MAC and IP addresses change or do not change. Because you might look at some of your network devices or some of your lab devices and say, I'm not sure where it's getting this MAC address from. So we're going to walk through an example of how and if MAC and IP addresses change as a result of proxy ARP. And two very simple rules to remember. The source and destination MAC addresses will only change when routers are involved, because that's when proxy ARP has to step in. The source and destination IP addresses don't change, period. So we will start that walkthrough on the very next video. See you there.